Okay, let's go over some trig stuff. So trigonometry is just the study of ratios of sides of a right triangle. So let's just kind of start with the basics here. So if you have a right triangle, and we call one of the angles theta, then across from theta, so across from theta over here is the opposite side. And then touching theta, so this side here is part of the angle, right? Part of the theta. So this is the adjacent side. And then lastly, I gotta get a different other color here. So then this side here is always called the hypotenuse because the hypotenuse is always across from the right angle. So the two legs make up the right angle and the hypotenuse connects those two legs. We'll label one of the angles as the one that we care about, and we're gonna generally just call it theta. And so across from theta is opposite and touching theta is adjacent. So now let's say that these triangles are similar. All right, these three triangles are similar. Now, how do we know that they're similar? Well, because they have, they've got three angles that are exactly the same. Now, I know I didn't write the number for that third angle up top, but there's only 180 degrees in a triangle, and I'm definitely having 90 degrees from the box symbol and 34.7 degrees from the angle which is labeled, and so the third angle has to be the same value, right, for all three triangles, whatever the difference is between 180 and the sum of the other two. So now, let's look at the sides of the triangle. So since these guys are similar, the sides should be proportional. So 6.4 should be proportional to 48.8 and is proportional to 51.2. And similarly, these bottom values, so 9.24, 64.68, and 73.92 will also be proportional to each other. So that means that it's the same multiplication to get from one to the next to the next. Now, since they're proportional, the ratio of the sides will also be the same. So if you wanted to use like your calculator and do any green angle or any green side over any pink side, that ratio should be exactly the same. Right? So green over purple or pink is going to be the same for every single one of these triangles because they're similar. So now that's also true with the hypotenuse as well. So the hypotenuse here, these hypotenuses are also all proportional, which means if we take any ratio, yellow over pink, pink over green, green over yellow, yellow over green, like you could do any of the ratios, make a fraction, and all of those ratios will be the same. Like all of the yellow over greens will be the same. All of the pinks over yellow will be the same. So now, let's see what happens here. So we would like to look at DE over DF. So DF is yellow. HJ is a yellow side from the second triangle, and PR is a yellow side from the third triangle. And similarly, they want DE, so I highlighted that in pink. So DE is pink, HI is a pink one, and PQ is a pink one. So what we're going to do is we're going to calculate the ratio of these sides, and according to what I've told you, they should all be the same value. So now, let's actually do some math. So DE is 9.24 and DF is 11.24. So if I get my calculator out here and do, oh no, I forgot the numbers already. 9.24 divided by 11.24. So 9.24 divided by 11.24. That's going to give me 0.82206. So 82206. And there was a lot more decimals on there. It's an irrational number, I'm sure. So now we want to round to the nearest hundredth. Hundredths, that's the second number. We look to the right, and it's either going to be 0.82 or 0.83. And we look one more digit to decide if we keep or bump. So this digit after the first two, after the hundredth space, is another 2. And so that tells me to keep it. So this ratio is 0.82. Now let's just try it with the next one. So HI over HJ. So HI is 64.68. And HJ is 78.68. And so now we're going to take the ratio of those two numbers. Let me get my calculator. 64.68 divided by 78.68. So that 78.68 equals, hey, look at that, 0.82206. So it's the same exact number, 0.82. And so it would follow, if you do the math for PQ over PR, that it would also be 0.82. So now let's calculate the sine of 34.7 degrees, the cosine of 34.7 degrees, and the tangent of 34.7 degrees. So I'm going to go into my calculator here, and I'm going to use tangent. So you can see up in top, it says degrees. So I'm in degrees. You can tell, I can't circle it, but it's up here on the top left. It says degrees. So, of course, now I forgot the angle. 34.7. All right. So let's try 34.7. So I'm going to put in 34.7. This is a little bit backwards of the Alex calculator. And I'm going to take the sine of that. So I have 0.56927. 0.56927, and they wanted me to round to the nearest hundredth. So it's either going to be 0.56 or 0.57. Since we look to the right's a bigger number, 5 and larger tells me to bump. So this would be 0.57. Now let's do cosine of 34.7 degrees. So 34.7 degrees, and I want to do the cosine of that, 0.8221. I have 0.822. So again, breaking that at the 2, I get 0.82. And then lastly, we'll do tangent of 34.7. So 34.7 tangent, 0.692. So again, breaking it at the 9, it's either 0.69 or 0.70, but the 2 tells me to keep it, so I have 0.69. So now, which one of these was the ratio of pink to yellow? Well, it looks like it would be the cosine, right? Now, let's just investigate that. We've got SOHCAHTOA. So cosine is adjacent over hypotenuse. So adjacent was touching. Hey, if this was the angle, this is definitely the adjacent side, and this is definitely the hypotenuse side. And so there you go. It looks like that was the cosine of the angle. So now, what if they don't give you all of the sides, right? Well, it turns out that we can find the sides of a right triangle by using the Pythagorean formula. So let me write that Pythagorean formula for you. That's a squared plus b squared equals c squared, where c is the hypotenuse, and a hypotenuse only happens in a right triangle. So there's no other triangles that this works for. So A and B are the legs that make up the right angle. So now we want to find the tangent of theta. So here's theta here. This is going to be my adjacent side. This is going to be my hypotenuse side. And this is going to be my opposite side. Now opposite I don't know, but I'm not sure if I need it. I'll know if I need it by looking at what trig function I have. So I'm asked for tangent. So that's the TOA part. So tangent of your angle theta is going to be opposite over adjacent. And you can see here that we've got adjacent, right? That was 7, but we have to figure out the opposite. So I'm going to let a squared be the one I don't know. So I have a squared plus, and now b is another leg, so I know 7. So 7 squared equals, and then hypotenuse, or c squared, 25 squared. So a squared plus 49 equals 625. And now I need to subtract 49 from both sides. So a squared is equal to 576. So now to figure out what a is, I have to take the square root. So a is going to equal the square root of 576. Now, I think it might be a perfect square. It might not. So I'm going to use my calculator first, because you see here it says give an exact value. So if you go in your calculator and it gives a decimal, then you have to simplify your radical and keep it as a radical. But if you do the square root of 576 and it comes out to like a nice number, perfect. So let's try it. 576, and then I need the square root. Oh, hey, that's 24. Booyah. So a is equal to 24. And remember, a was over here. This was our opposite side. So opposite is 24. So the tangent, or the ratio of the triangle with that angle theta, will be 24 over 7. Let's try that just one more time here. So here's my picture. Theta, 7, 4. I've got a right triangle. And I'm going to find secant, cosine, and cotangent. So first of all, cosine. So let's start with cosine. So cosine of an angle is adjacent over hypotenuse. So I already know that in my triangle here, I've got the opposite and the hypotenuse. So I definitely need the adjacent. So let's just solve for it now. Remember, 7 is our c. So we'll have a squared plus 4 squared equals 7 squared. So a squared plus 16 equals 49. Now I have to subtract 16 from both sides. So I have a squared equals 33. So a is the square root of 33. Now, if you go in your calculator and you do the square root of 33, let me just show you here. Come on, calculator, 33. Square root. Oh, bummer. That's a big old decimal. So we're not going to use it. We're going to keep it looking like the square root of 33. And we're going to try to simplify that. So now 33 is 3 times 11. And 3 and 11 are both prime. So since there's no doubles, my radical doesn't simplify. So this is just going to stay looking like the square root of 33, and that will be my adjacent side. So right away, I can do adjacent over hypotenuse. Adjacent is the square root of 33 over, and then hypotenuse is 7. Now when you're doing this in ALEKS, first I would put in your radical or your fraction. And so that like automatically gives you this as your input. And then second, use your square root button when you're up here. Because if you, because this is just the square root of 33 and then that whole thing is over 7. You don't want to put the over 7 in with the square root. It needs to be outside the square root. Now I've got these like weird ones, right? Like I know SOHCAHTOA, sine is opposite over hypotenuse, and then cosine is adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent. But now I've got secant and cotangent. So it's really important to remember some, like just kind of the most basic relationships here. So the secant of an angle is the reciprocal of the cosine of the angle. So if cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. So let's do that. So secant of my angle will just be the flip of this. So 7 over the square root of 33. Now in math, for some reason, I don't know why, we don't like radicals on the bottom. So we're going to rationalize this denominator here by multiplying it by the square root of 33. Well, why would I do that? Well, if you multiply a square root by itself, it cancels the radical and you just have 33 on bottom. But I have to also do it to the top. That's a clever form of 1. And so on top, I have 7 times the square root of 33. That's called rationalizing the denominator. And now, since we have numbers which are not in the radical, we've got a 7 and also a 33. Those guys are not in the radical, they're outside. So if those guys could simplify, like if they both shared a factor, cool. If they don't, cool. So now the answer to this guy will be 7 times the square root of 33. Big divides 33. So when you type this in, make sure only the 33 is under the radical up top and everything else is outside of the radical. So now cotangent of an angle is the reciprocal of the tangent of the angle. So SOHCAHTOA, tangent is opposite. So let's just write that down. Tangent of an angle is opposite over adjacent. So this will be adjacent over opposite. So here I've got my adjacent is the square root of 33 over. The opposite is 4. Now again, make sure that 4 is not in the radical part. So now, another thing we can do with these expressions is simplify them. So when you're simplifying a trig expression, you're only going to use some basics, all right? So for example, secant of an angle is 1 over cosine of an angle. Cosecant of an angle is 1 over sine of an angle. A tangent of an angle is sine over cosine. What? Sine over cosine? Let's think about that just for a second. So sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle is opposite over adjacent. That's your SOHCAHTOA. Well, it turns out that if you do sine, which is, so sine of an angle, if you do that, that's opposite over hypotenuse. And then if you divide that by cosine of the angle, cosine of the angle was adjacent over hypotenuse. Fraction math says keep, change, flip. So we would do opposite over hypotenuse times, so I'm changing this divides to times, and now I have to flip this guy. So hypotenuse over adjacent. And what happens in the fraction is that you've got hypotenuse on top and on bottom, and it just becomes opposite over adjacent, which was boink, tangent. So tangent is sine over cosine. So now we also know that cotangent of an angle is the reciprocal of tangent of the angle. But in this case, we can flip sine and cosine, so it would be cosine of an angle over sine of an angle. So it turns out if you know sine and cosine, you get the other 4 trig functions with just a little bit of work, just a little bit of algebra, but not any more trig. So these guys are going to be your basics for simplifying trig expressions. So when in doubt, just change everything to sines and cosines and see what happens. You have to use like real algebra math though. You can't like just make up how to do things. Like you saw me, I used keep, change, flip. That's real math. That's real algebra. All right, so this is what I have. In this guy, I've got cosine times secant. So what I'm going to do is I'm going to write both of these in either in sines or cosines, however the function is described. So cosine of x, well, that's still just cosine of x, right? Now, secant of x, and cosine of x stays cosine of x, but secant of x, oh, that one is not a sine or a cosine, but I do know that secant is the reciprocal of cosine. So instead of writing secant, I'm going to write 1 over cosine. So now regular, like I've done all the trig I need to do. Now this is just algebra. So I'm multiplying 2 fractions. This guy technically has a 1 on bottom. So I'm going to go straight across and I'm going to get cosine of x over cosine of x. And now I know cosine of x is like kind of a weird thing, but when you divide something by itself, it's always 1. So we're using algebra and fundamental trig identities, and our answer is either a number or a single trig function. So here, this can simplify into just 1. So if you can use your calculator and pick an angle, 25 degrees. Take the cosine of that angle and then take the secant of that angle and multiply those two numbers together, and you'll get 1. Since your calculator only holds a certain number of decimals, you might get something like 1.000000001 or 0.999999992, but they'll be close enough that, you know, without loss of generality, because you're taking irrational numbers and basically cutting them off in your calculator. All right, so that's kind of the a few parts of trig that I saw people were having trouble with.